Now let's try getting something back out of our array list using get. It works kind of like the square brackets in a regular array. You pass it an index value and it retrieves the object at that index. Like an array, ArrayList is zero-based, which means the first item is at an index value of 0. So if we have a new array list called items, we're going to add peanut butter. So now this is at an index value of 0 since it's the first item in the list. Then we're going to want to print items.getZero. This will print peanut butter. However, if we have string s equals items.getZero, this causes an error, which doesn't make sense yet. We're going to go over that next. Oh no! We can print out our item just fine, but trying to assign it to a variable causes an error. Incompatible types. Object cannot be converted to string. So what happened here? ArrayList items was never initialized as a string and therefore cannot store any of its items as such. This has to do with the difference between object and object. So here we have our ArrayList items. It is not a string, therefore we cannot save anything in it as a string. The problem is that capitalized object is different from the objects we've been talking about. Object is a class, like string, ArrayList, scanner, and system, although not one you probably will ever use directly. You will learn more about the object class and how it relates to the other classes in the unit on inheritance. But for now, what you need to know is that in order to use ArrayList with classes other than object, we just have to tell it which class to use. Java has a feature called generics. Normally, when we create a field or a variable, we've been defining the type. For example, string name equals John creates a variable of type string. Int number equals 0 creates a variable of type int. Generics allow Java programmers to create generic variables without a type that will have their type defined later. ArrayList was originally written this way, so that future programmers like us can decide what kind of objects it will hold. To use ArrayList, we just have to define our ArrayList with the type in angle brackets. ArrayList E, Greek equals new ArrayList E, where E stands for the type of element the list will contain. Let's see how it works. So we have our new string ArrayList called Greek, then we can add a string to it, add another string to it, then we can save these things into strings. So string beta equals Greek.get1. This will go to the index value of 1 and save whatever's in here into this variable here. So this saves beta into string beta, and note there's no more errors. By the way, we can save ourselves a small amount of redundant typing and reduce the chance of making mistakes by using empty angle brackets when we create an array list with new. When we assign it to the variable, it will adopt the correct type. So we can declare it like this. We don't have to write string again in this second pair of angle brackets, but either way works fine. In addition to making it possible to get back the same class that we put in, defining our array list this way helps us avoid errors by warning us if we try to put the wrong kind of object into our list, like below. Here we have an array list of strings. We add alpha and beta. We try to add a double, and this will throw a compiler error. Incompatible types. Double cannot be converted to string. It is easier to let the compiler find errors at the time the file is compiled than for us to diagnose and fix runtime errors. Back in cart, let's now replace our ArrayList objects with string objects. So we're going to add this and this in there. So this ArrayList holds strings instead of generic objects. So now we can add an item, we can print out an item using get, but we can also save whatever's in that index value using get and saving it into string s. So there's no more error. It assigns s to store peanut butter.